Welcome to my YouTube channel. I'm Atu Francis Diba. Please subscribe and press the like button. Today we're going to be taking questions on determination of mole ratio. Determination of the mole ratio, that's what we're going to be dealing with. So like we normally do as usual, we're going to have our given. After going through the question, then we'll resolve them as we should. You remember the formulas, we've treated the formulas about amount, which is mole, number of moles. We have all of them handy so that we'll be able to resolve this without having complications. So go through them again in case you are having doubt or anything confused about. So our first question here is, A is a solution of a mineral acid containing 0.10 mole of the acid per dm cube of solution. B is a solution containing 1.3325 gram of anhydrous sodium triisocarbonate 4 per dm cube of solution. 25 cm cube portions of B was titrated against 6.30 cm portion of A. Calculate the number of mole of acid, which is the amount of acid. B, the number of mole of sodium triisocarbonate 4 in the volume of B. C, the mole ratio of acid to base in the reaction. And D, we should suggest what the acid in A could be. Give reasons for your answer. Then write the equation for the reaction. So we're going to start with our given as usual. So let me start. A for acid and B for base. So we say the molar count of the acid is 0.10. So our Ca 0.10 mole per dm cube. B is a solution containing 1.325 gram per dm cube. So we have 1 point for B. Cb is 1.325 gram per dm cube. GDM cube. So this is our mass concentration of the base. And the base is sodium triisocarbonate 4. That is sodium triisocarbonate 4. That is our base. Our acid, this is a mineral acid, so we don't know what it is. So 25 portions of B. So volume of the base is 25 cm cube. Was titrated against 6.30 of A. Volume of the acid is 6.30 cm cube. Portions of it. So we calculate one, the number of mole of acid, which is the amount of the acid. So remember, we have various formulas. Amount is mass over relative molecular mass, and we also have amount equals to molar count times volume, volume in dm cube. So in this case, we are going to be using of the acid. Remember, we're going to be using molar count times volume in dm cube because we have the molar count and we have the volume given. So we move straight forward to use that. So our A, amount of A in mole, of course, is molar count of A times volume of A. Now, the molar count of A is given to be 0.10 mole per dm cube times the volume is 6.30 over 1000. Remember, we are converting the cm cube to dm cube because the formula says molar count times volume in dm cube. So we convert the cm cube to dm cube by dividing by 1000. So I have my dm cube here. So this is 0.10 mole per dm cube times, so I'm going to use the calculator. I have 6.3 divided by 1000, which is 0.0063 dm cube. So this is equals to dm cube will take care of this dm cube, And what is left is mole. So I multiply 0.10 times 0.0063 times 0.10. I have 0.00064. Am I right? Yes. 63, sorry. Mole. So remember, the unit for amount is always in mole. So our first question, which says we should calculate the number of moles of the acid. Here it is, 0.0063 mole. So let's look at the next question. They say we should calculate the number of mole of sodium triacylcarbonate 4 in the volume of B. Now, the number of mole of sodium triacylcarbonate 4. Now, we can't use the same formula directly as molar count times volume, because we do not know what the molar concentration of the of the base is. And we can't use CAVA to get the molar count. Why is that? It's because they say it is a mineral acid. We don't know what the acid is, so we will not be able to balance the equation of reaction to know the number of mole of the acid and the number of moles of the base, which is our Na and our Nb. So because of that, we have to use a different way to get our molar count of the base. Therefore, we now apply it with the volume to get the amount. The formula we're going to use is molar count is equals to mass concentration over relative molecular mass of the base. Because from here we can determine the relative molecular mass of sodium triacylcarbonate 4, and we know the mass concentration since they've given that to us. So before we start solving our B, amount of B, we first of all get the molar count of B. So that's what we do right now. Now, this is amount of B. But we first get our molar count of B. Molar count here is con, means concentration. Therefore, molar count of B, the molar concentration of B is mass count of B divided by relative molecular mass of B. And this is, the mass count is given to be 1.325 GDM3 over the relative molecular mass of this compound is 106 G mole. So when we divide that, let's see what we're going to get. 1.325 divided by 106. 0.0125. 0.0125 mole per dm3. So we've been able to get the molar concentration of the acid. So I'll call it, sorry, this is GDM3, not CB. This is GDM3. Now our CB now is 0.0125 mole per dm3. Okay. Although I've forgotten what the other one was, I think I'll remember that of A. I'm supposed to take note of that. Now, moving further, I have gotten my molar concentration of the base, so now I can proceed to get the amount of the base. So, permit me, let me clean the board to get amount. Therefore, amount of B, which is our B, amount of B is molar count, yes, molar count of B times volume of B. The molar count of B is 0.0125 mole per dm cube times the volume of B is 25 over 1000. Remember, it's always in dm cube. Now this is 0.0125 mole per dm cube times 25 divided by 1000, 0.025 dm cube. Okay, if this cancels this, we are left with mole. So our answer now is that times this times 0.0125 is equals to 0.0003125 mole. In three significant figure at 0.000313 mole. So now we've taken care of our B. Our C says the mole ratio of acid to base. So let me put it here. Amount of B is 0.000313. Amount of A. Oh, I forgot what it was. Let me quickly press that. 6.3 divided by 1000 times 0.1. Amount was 0.00063. Okay, so now we've gotten our B question, which is the amount of the base, which is this, and that of the acid is 0.0063. So the next thing it says the mole ratio of acid and base. So I can take out this and bring that in. Mole ratio of acid to base. This is my acid and this is my base. Acid is 0.00063. This is 0.000313. So how do we get that? We divide by the lowest, which is this, which is 0.000313. 0.000313. Here will give me 1, and here will give me what? 0.00063 divided by 0.000313 give us 2. So this is our mole ratio is 2:1, as the question suggests or asks. Now let's proceed further. Suggest what the acid in A could be. Give reasons for your answer. They say that what the acid write the equation for the reaction. So if the mole ratio of the acid is 2:1, the acid obviously is not dibasic. Obviously, it's clear it's not dibasic. So if it is not dibasic, let us write the equation for the reaction. So I can have this now for the equation of reaction. So I have HCl plus sodium CO3. This is monobasic because it's 2 mole, let's say. And another acid that can give us that is HNO3, trioxonitrified acid. 2 moles of HNO3 plus sodium triazocarbonate 4. So these are the 2 acids which can be monobasic. So therefore, here we are going to get our sodium chloride plus water plus CO2. Here is sodium nitrate, sodium nitrate, NO3, plus water, plus CO2. Let us now balance it. We have two hydrogen, fine. We have chlorine 2, we have 1 here. So it's not balanced here. Sodium 2, we have 1. So if I put 2 here, I'll have 2 sodium, which is correct, and I have 2 chlorine, which is correct. Now let's proceed. We have water, H2O. So hydrogen is now 2, we have 2 for hydrogen. Oxygen is 3. I have 2 plus 1, 3. Remember the state of the reaction. This is aqueous. Aqueous, liquid, and gas. So we can take the next question quickly. And this is what we get. They say 25.2 cm cube of a 0.0505 mole per dm³ solution of a mineral acid neutralized completely 25 cm cube of a 0.101 mole per dm³ solution of hydrogen chlorocarbonate 4. Calculate the amount of acid, amount of base, C, mole ratio of acid to hydrogen chlorocarbonate 4. So we can take this quickly too. We start with our normal given here. So in the given, acid is, the concentration of the acid, let's call it Ca, is given to be 0.0505 mole per dm³. The volume of the acid is given to be 25.2 cm³. Neutralize completely 25 of B, so volume of the base is 25 cm³, and the concentration Ca is 0.10 mole per dm³ of hydrogen chlorocarbonate 4. So here is hydrogen triisocarbonate 4. So this is obviously going to be 2. Of hydrogen triisocarbonate 4. Calculate amount of acid used. We don't know what the acid is, a mineral acid. A. Amount of acid used. Remember, okay, amount of acid used is equals to molar count of A times volume of A. Now the molar count of A is given to be 0.0505 mole per dm³. Times the volume of acid is 25.2 over 1000, or in dm³. And this is equals to 0.0505 mole per dm³ times, we have to check our 25.2. 25.2 divided by 1000, 0.0252. 0.0252 dm³. Amount, therefore, this will take out this. Therefore, that times this times 0.0505 is 0.00127 mole of A. So that's the amount of A. Then the B, what is the question? The B says amount of base used. Now amount of base is also direct, which is the molar count of the base times the volume of the base. So we proceed further. Let me clean that. B. B, amount of B used is equals to molar count of B times volume of B. The molar count of the base is 0.10 mole per gm cube times the volume is 25 over 1000 in gm cube. And this is equals to 25 divided by 1000, 0.025. Times 0.025 gm cube. Now when we multiply that with 0.1, what do we get? Times 0.1 is 0.0025 mole, because this will cancel this. So this is our amount of the base. Now, like the other one, let's say the C says mole ratio of acid to hydrogen trioxocarbonate 4. There again, I forgot. Let me put the value here. Amount, this is BO, BICO. Amount of the base is 0.0025 mole. Amount of acids is, let me check that quickly, 0.2 divided by 1 times 0.050 is 0.00127 mole. Yes. So now they say we should calculate, where is it? We should calculate the mole ratio of acid to base. Now the mole ratio C. C, mole ratio of acid to base. So this is my acid and this is my base. That of acid is 0.00127 and this one is 0.0025. Okay. Now, which one is the biggest? 1 and this is 2. So divide by this, which is 0.00127. 0.00127. Here is 1 is to 0.0025 divided by 0.00127 is equals to 1.9, approximately 1.9, which is approximately 2. So the mole ratio of acid to base is 1 is to 2. So we're done with that question. Let's take the third question. Okay, the third question now. It says write 3A. Write a balanced chemical equation for the complete reaction between dilute tetrazosulfate 6 acid and aqueous sodium hydroxide. Okay, I think this one is small. Alright. We should write the balanced chemical equation for the complete reaction between dilute tetrazosulfate 6 acid, dilute H2SO4 with aqueous sodium hydroxide. Sodium hydroxide. We balance sodium sulfate plus water. It's a neutralization reaction, the reaction between an acid and a base. It's neutralization, which products are majorly salt and water only. So let's proceed. We have 2 hydrogen here, we have 2, correct? SO4, SO4, 1 sodium, 1 sodium, hydrogen now 3, hydrogen there 2. So if I put 2 here, hydrogen will be 4. I put 2 here, hydrogen will be 4. Now sodium is 2, I can put 2 here. So I think this is good. We are good, we are good, we are good. So this is aqueous, and liquid. That is the A section. We're done with that. Let's look at the B section. It says that if 20 cm cube of 0.125 mole per dm cube of tetrazosulfate 6 acid solution reacted with a solution of sodium hydroxide, calculate the amount in moles of sodium hydroxide required for a complete reaction. Okay, in this case, they're giving us the variables that can give us the amount of the acid, because they're giving us the volume of the acid and the molar concentration of the acid. That can give us amount. And now this other side of the base, what is the base again? Sodium hydroxide, nothing was given. So in this case, we can only use mole concept to resolve that. It's very important we know how to maneuver ourselves around that. So let's see in the balance equation how we can go about it. So this is it. Down here, this is the equation of the reaction. And let's say 20 cm cube. I want to get the amount of A, then put it here so I can use mole concept. Now amount of A is equal to the molar count of A. Molar count of A times the volume of A. Now the molar count of A, they gave it to us to be 0.125 mole per dm cube. Ca. 0.125 mole per dm cube. So I have 0.125 mole per dm cube. And the volume of the acid is given to be 20 cm cube. Yes, 20 cm cube. I think that is all. So the volume here times 20 over 1000 in dm cube. So if I have my 20 divided by 1000, I have 0.02. So this is 0.125 mole per dm cube times 0.02 dm cube. So when I multiply these two, I get amount of A, and that will be times 0.125 will give me 0.0025 mole. So this is the amount of the acid. Remember, let me go through the question again. It says that if 20 cm cube of 0.125 mole per dm cube of tetrazosulfate 6 acid solution reacted with a solution of sodium hydroxide, calculate the amount in moles of sodium hydroxide required. No other variable was given to us for the amount of sodium hydroxide. So the only way, I think that is the reason why they asked us to balance the equation, is to use the mole concept, where we have already established the given. 1 mole of this gives us 2 mole of this, then 0.025 mole of this will give us what of X, what of sodium hydroxide. That's what we're going to do right now. So now we come back. Here I have an established rule, which is 1 mole of tetrazosulfate 6 acid give us 2 moles of sodium hydroxide. Therefore, 0.0025 mole of this will give us X mole of sodium hydroxide, X mole of B. Pardon me, let me clean this side. Therefore, my X mole will be X mole, okay, of B will be 0.0025 mole times 2 mole, which will give us Okay, times 2 give us 0.005 mole. So this is the number of moles of the base of B. And that is what they are asking of us to get, of B. So by so doing, through mole concept, we've been able to establish what we actually required, although they didn't give us much information from this side, but with our knowledge or an in-depth knowledge of mole concept, we can move around, these things without much problem. We will deal with, remember I said we're going to deal with mole concept later on for easy application. So, thank you.